there's your warm-up for dividing rational expressions. And again, the process for dividing rational expressions, pretty straightforward. All you're going to do is multiply by the reciprocal of the divisor. So in this first problem here, we take 4/8, and we don't multiply it by 1/3 because that's not the reciprocal. You have to multiply it by 3/1. If you'll recall from yesterday's lesson, when we multiply fractions, you just multiply straight across. So you do 4 times 3, and that's 12. And then you do 8 times 1, and you would get 8. Of course, you can't leave me an answer that looks like 12/8. You have to reduce it to lowest terms. That fraction does reduce to 3/2. I reduced out that common factor of 4. For number 2, I did a little cross-canceling like we did yesterday. Talked about that. Number 2, your answer there is 3. Number 3, your answer is 2. And number 4, your answer is 8x/3. Does anybody have any questions about the warm-up? Because if you can't do division with like simple numbers, today we're going to divide rational expressions. And if you can't do regular division with fractions, then division with rational expressions is really complicated. We're going to use the exact same steps that we did here as we do with rational expressions. So the algorithm or the step-by-step process for getting the problems done actually doesn't change. It's just how we go about executing that algorithm that changes a little bit. Okay, so with that, let's do this. To just kind of talk to you a little bit about the process, what you're going to see today are problems that look like A/B divided by C/D. And just to drive home the point, you never really divide fractions. We actually always treat that as multiplication. We actually multiply by the reciprocal of the divisor. If a runner runs, a baker bakes, a teacher teaches, a divisor is the thing that does the dividing. It's your second fraction in the problem or the fraction that's on the bottom that takes care of the dividing. So it's for this reason that C/D is what we call our divisor. It's dividing into A/B, bless you. So you flip, you take the reciprocal of that divisor, so that'll be D/C. And then we just, kind of multiply through. Of course, this is all true only if B, C, and D aren't 0. That would violate our rule that's against dividing by 0. Today's lesson is just different from yesterday's lesson by 1 step. I'm going to add 1 step to your process. So we're going to write 4 steps instead of 3. You're only going to write them down once, and then we're just going to do the problems after that. Right here we have a ratio of ratios. What we're going to go ahead and do is, in step 1, I notice that I'm dividing 2 fractions, and I can't do that. I'm going to multiply by the reciprocal of the divisor. In other words, I'm going to rewrite this problem as multiplication. So I literally, it's like a clerical step, I literally just rewrite the problem. So there's my numerator. And I have to rewrite it as multiplication by the reciprocal of that divisor. So I have to flip that fraction on the bottom there. So this will be 4x squared minus 16 becomes my second numerator. And then x squared minus x minus 12 becomes my second denominator. So I multiply by the reciprocal of the divisor. What's up? You can factor first. I don't necessarily see a problem with that. Does anyone have any questions about what I did here? That's just step 1. Okay, step 2, Jonathan kind of stole my thunder. Yeah, we're going to go ahead and factor everything in the problem, just like we did yesterday. X plus 3 doesn't factor. X squared minus 4 does factor via my square root method. It's a difference of 2 perfect squares. 4x squared minus 16. I noticed there, you know, when we factor, we always try to take out that greatest common factor first, so I am going to do that. Take out my 4. And then I have x squared minus 4 left over. This actually factors again via my square root method. And then on the bottom, I'm thinking about the factors of negative 12. That would give me negative 1. That's going to give me minus 4 and positive 3. You could also do AC grouping on that one. That was an option for when we had 3 terms. Any questions so far? Okay, next. The next thing I want to go ahead and do with you is step 3. We cancel or reduce out factors of 1. So that's our next step. So step 3, we cancel factors of 1. Or reduce out factors of 1. Essentially what that means is we're allowed to cancel in 2 directions. Remember, we're allowed to cancel from top to bottom, vertically. And you can cancel across the multiplication, so diagonally. Cross cancel is what I'm trying to say there. Just like you did yesterday. So as I look top to bottom, x plus 3 over x plus 2, x minus 2, nothing's going to reduce out of that first ratio. Second fraction, I don't see anything that reduces out there either. So I'm going to take some time right now to now look diagonally across my product and try to cross cancel. And I do see that I can get rid of some stuff. This x plus 3 will reduce out with that x plus 3. X plus 2 reduces out with this x plus 2. X minus 2 reduces out with that x minus 2. So not too bad. And then for that, we will take some time to, in the last step, multiply and reduce if possible. So we'll do that. You know, I always say reduce, just in case you forgot to cancel a factor. Remember, these green slashes kind of behave a lot like 1s. So we have 1 times 4 times 1 times 1. That's just 4 on the top. And then I have 1 times x minus 4 times 1, and that's x minus 4. And now I have to reduce if possible. So I'm going to throw that out to you guys. Can you reduce those 4s? Can you cancel that? What do you think? John? No, do you know why? Right. That x minus 4 is the factor on the bottom. If I wanted to reduce that, I would not need another factor of x minus 4. That's a nice way of looking at it. I like that. Remember, the 4 on the bottom is what we call a term. It's touching a minus sign. Anything touching a plus or a minus sign is kind of what we call a term. You can't cancel terms. It's a rule. When I was a student, I do remember this from my high school career for sure. I would look at that problem. I second-guessed myself. I would be like, can I cancel those 4s? True story, sitting in your seats. I asked myself the exact same question. So let me show you what I used to do as a kid, like how I sort of like figured it out for myself. Like, you can't cancel the 4. So like on my test or on my quiz or on my homework, I would sit there and I'd look at that problem like, oh, you know, can I cancel those 4s? And I doubted that response to that question for a long time. So here's me thinking about this problem when I was like, I don't know, 16 or 17 or whenever. I'd look at these 4s here, like, oh, can I cancel them? And hypothetically in my head, I'd be like, all right, let's cancel and see what happens. And I think if I canceled those 4's, I'd be left with something like 1 over x. I'm like, all right, well, is this 1 over x now equal to 4 over x minus 4? Let's run that math and see. Now, to check it, I would just kind of like pick a number for x. So let's see here. I need a number for x. What? Eddie, what'd you pick? Okay. I thought I heard like thousands. I was like, what? Now, like, this is a test. Time is of the essence, right? So I'd pick a number like 5, like Eddie just did, you know? Throw in your 5 in for x here. I'd be looking at 1/5. Well, then I'd take a minute and I'd throw my 5 in here too, and I'd run the math, you know? We'd be doing 4 over 5 minus 4. Well, 5 minus 4 is 1. 4 over 1 is in no way equal to 1/5. So I couldn't reduce, is what that kind of told me. I didn't get an equivalent expression there. Remember that they have to work for all values of x, and what I just produced was a counterexample. So 4 over x minus 4 isn't the same as 1 over x. So you can play that game, you know, if you're really concerned, genuinely concerned about is this completely reduced, reduce it and play around with it. See if it's equivalent to the expression that you didn't reduce. Cool trick. Questions about that? In addition, you know, let's say you're going through and you're like, oh, it's an even problem in my homework tonight, and I'm not sure if I did it correctly. You can always, here's what's cool about checking these problems, you can always take your answer, and again, pick a number for x like Eddie picked 5, and then in your original problem, plug in 5. You should get the same number. It's a little bit of work, but you should get the same number both times. So that's kind of cool. Questions about this? Because these are the steps we're going to use. We're going to do one more together, and then I'll cut you loose on the independent practice and conclusion questions. So in part B, I see division, and I'm like, oh, we can't divide. So the first thing I do is I rewrite my problem as multiplication. So I'm going to rewrite this as a multiplication problem. Okay, so I rewrote it as a multiplication problem, and the next step I just factor everything that's there. So I'm going to take a moment now to factor x squared minus 1. I know that I could run my square root method on that because it's a difference of 2 perfect squares. X minus 5 doesn't factor. X squared minus 3x minus 10. So I'm thinking of factors or things that multiply to give me negative 10 that could add to negative 3. X minus 5 and x plus 2 would FOIL to give me x squared minus 3x minus 10. And then on the bottom, x plus 1 doesn't factor. Next, I reduce out factors of 1. You can cancel top to bottom, and you can cancel diagonally. So I'll take some time right now to go ahead and do that. Does anybody have any questions on how I factored any of that first? Good. Okay, so right now, x plus 1 and x plus 1 factor, and then x minus 5 and x minus 5 factors. So what we get is x minus 1 and x plus 2 as your final answer when you multiply straight across. Nope. Yeah, you don't have to FOIL it. I think your book FOILs the answers in the back, but as long as I've been teaching this particular course, we just left our answers in factored form and reduced. All right, so how about you give it a try? Let's see how it goes. I'm going to finish checking off a couple homeworks. Okay, so here's your answer to part C. You'll see I walked through the steps. First, I set it up as multiplication, and then I factored everything in the problem, and then I reduced out my factors of 1 to write my answer, x plus 2 over x minus 2, x minus 1. How do we do on that one? Good? Questions? All right, next one. You want to see part D, I would assume. Oop. I don't want to show you the independent practice yet. Sorry. So there's our answer. Bless you. Our answer to part D. Good with that? All right. And then you have that for your independent practice. There are a couple conclusion questions there at the bottom. I would like you to take some time to answer those for sure. And then really you only have 3 of these for tonight. So if you have your book, you could probably get those started. It looks like you have a couple minutes. And your conclusion questions, of course, at the bottom. So those conclusion questions there. It says, in your own words, what are the steps to simplifying a rational expression? I say, Mrs. Lucas, why do you put these questions at the end sometimes? I don't know where I picked up this little tidbit of information, but somebody once told me that if you know it well, you can explain it to somebody else. So I put these questions in here, and I make you kind of explain it to me. And if you can put it in your own words correctly, that means that you really know what you're talking about. They say if you can teach it to somebody else, it means you really know the material. That'll be handy for you in college if you're worried about something, or even in your tests that you take now when you're preparing. If you can run through the vocabulary words for your anatomy class or whatever it is, and you could teach those terms to somebody else, then you know what you're doing. And then in number 2, it says, then in your own words, what are the steps to multiplying 2 rational expressions? And then lastly, in your own words, what are the steps to dividing 2 rational expressions? You're going to get a quiz for me next week. The quiz is 3 questions. You have to simplify, multiply, and divide rational expressions. It's real quick. 3 problems, just like this note sheet. So that's good stuff. Domain questions come up again on your test on operations with rational expressions. So all in all, our next test is going to be on, I guess, a total of 6 things. You have your domain. Then you have to simplify rational expressions. And then we add, subtract, multiply, and divide rational expressions. So those are your 6 things that you'll be able to do by the time you get to your next formal assessment for me. Questions about that? You do have homework tonight. You have 3 problems. No rest for the wicked, right? 3 problems. You'll be all right, Darius.